Hey guys, welcome back to another episode of Wrench Tales. We're on episode number 17, and we're back with my good buddy Keith Perkins of L1 Auto out in Tulsa, Oklahoma. And guys, you don't know what it took to get me to pin this guy down. I had to have Liz give him a lollipop so he'd sit still and I could strap his ass to a chair so I can get him to talk to me because he's running around like his hair's on fire. But no, all joking aside, buddy, thanks for taking the time to be here with us. We all know how busy you are, and we appreciate you sharing your knowledge with us.
Nah, thanks, Brandon. It's always a blast.
Awesome. How you doing tonight?
Ooh, tired, ready to get done with the evening and take some R&R time.
I hear you, buddy. I bet that was a stupid question. I'm sorry. Well, we're gonna get right into it. So you know what? For you can see my screen, can't you, Keith?
Oh yeah, we're all good.
Perfect. I just wanted to make sure. You know, I love dealing with Keith on these things because as most Keith is he'll never admit this and he'll be the first to argue with me, but he's a cut above the rest. And what I mean by that is his mind works at another level. And it's not all genetic. He's put in a lot of time and effort, and his background lies with computers and electronics before he even became this master automobile technician and instructor, international extraordinaire. So but when I hear of situations when Keith encountered a learning moment, I giggle a bit, but then I say, let's grab a beer and talk about this because it's going to be a learning experience for me. And it really was when you told me this story, Keith. But I call this one jokingly battling insomnia, and you guys will see why coming up. But Keith, if you wouldn't mind, do us all a favor. First of all, I got to say, I apologize. I can't remember who reached out, but somebody at some point pretty much told me to shut my mouth. They said I talk too much. And I think it was during our last episode together, Keith. So I apologize if I stole your limelight. I'm just trying to hammer home some points and make sure we get all the goodness out of everything you're trying to share with us.
No, it's better because I may tell you the story how I remember it, but from a viewer standpoint, you've got all the right questions, man. You're the interviewer extraordinaire.
That's what I'm trying to play is what might people be thinking if they didn't know what you know, and now what I know only because you
Yeah,
educated me.
yeah. I was like, I'm
So
cheating. I already knew the answer.
that's the best part. The fact that you share it with us instead of just saying, look what I can do. So battling insomnia. Keith, tell us about this. Like you told me, tell me about this F-150 you were talking about.
Yeah, so to set the stage a little bit, I was actually contracted to come out to a shop and teach, and we were doing a diag class. And I always tell shops when we do this, don't gather up cars that we bug or any. I hate bugged cars. Bugged cars don't rarely happen in real life. So I just tell them get all of the diags you've got stacked up. Call the customers that you've been having a lot of problems with a certain issue, and get the cars there, and we'll try to learn a technique and apply it in class. So this was unique in the fact that this was one they had been battling for a couple weeks. And a good friend of mine who's a mobile tech in the area had already taken a couple stabs at it and got all the way to the answer. And I said, hey, don't tell me anything. And then part of the way through, he gives me some advice that's super helpful because I would have misdiagnosed this first right off the bat. So I'll let you know when we get there that I probably would have done the same thing without a little bit of information. But the complaint goes like this. The truck comes in and I have a couple questions about it we weren't able to answer. But essentially, if you start the truck and you drive it, you can drive it 5 minutes, 2 minutes, 10 seconds, doesn't matter. If you shut the key off and turn the key back on and you start the truck once or twice, typically within the second or third key cycle, the truck no longer cranks, gives you a starting system fault and you can open and close the driver's door and it will crank again and start and run. And you could do that cycle over and over and over again. And I mean, as part of a basic diagnostic process, we made sure that we could replicate that concern over and over again. I mean, a dozen times in 10 minutes, we were able to cycle the key, start, run, start, run, start, run, stop cranking, open, close door, reset the cycle. And so in my mind, my first question was, how did the customer figure that out? Because I don't remember the last time I got in my truck, drove somewhere, and stayed in my truck and started the truck back up and went somewhere else again and again and again. And I
You
don't
know,
know.
I know what he figured out. When he got pissed off, he went back in the house and said, "Honey, get your keys and take me to work. This damn truck, blah 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 blah. Hold on, I
Yeah.
forgot my lunchbox." And he goes back
Yeah.
out and tries it again, and now
Yeah.
it's fixed.
Yeah.
So you
Yeah.
confirmed this problem vanishes when you open the door.
Yeah. If you open the door, close the door, you know what? I didn't know. I didn't check to see if you just open it, if it would do it, but you open the door and close the door, it'll start again.
Got it. So naturally, when you told me this story and you didn't first tell me what was wrong, of course, being a diagnostician, my mind's going. And it goes here
Racing.
to this road sign.
Yeah.
Which way do we go with this? And I got to consider those clues you told me. And I know you do the same thing. And the reason why I'm harping on this so much is so many people ask me, and I know they ask you this, Keith, is like, what makes people like you and myself that talk about this stuff, what makes us any different? I don't want to use the word better, but any different than somebody else? Like, why can we figure this stuff out? And so struggles a little bit more. It's one of those, A, things like this, we get our butt kicked.
Yeah.
B, we learn from it. But considering the possibilities, consider all that information Keith just rattled off, the importance of what seems insignificant now, opening the driver's door. You know what I mean? Who cares? What happens when we open the driver's door? That's what comes to mind. Why would the vehicle now start? Does it have something to do with the ECU resetting somehow? Do the DTCs, if there are any, do they get cleared? So
Yeah.
those are the things I have to consider. Is it something that's load related, like perhaps a dome light, or maybe the headlights come on as like a twilight set now, and it creates some sort of electrical load that takes away this fault. Maybe there's a voltage drop somewhere. Considering today's configurations, what happens when we touch a door handle? Right, dome lights come on, and maybe fuel pumps prime.
Yep.
Um, and these are just at this moment in time, they're just thoughts going through my head, and that's why I wrote them down on a slide here, because we've got yet to prove anything, but it's certainly okay to start thinking about
Yeah,
the
and that's a good point.
possibilities.
When people ask us like what makes us different or our process different, it's that we're thinking about how the vehicle works, what symptoms exist, and what problems could exist in the car that would exhibit these symptoms and give us this kind of fault. And that's where we do have that which direction do we go and why are we thinking about these things? Because we're just plugging in description and operation and symptoms to see where there's a cross, where the two paths meet to come up with a
Yeah.
probability of a fault of where it would be and and more importantly, sometimes what it can't be.
Yes. And that has been my go-to for the last several years now is what do we not have to test? Right.
Yeah.
Obviously, it's not a starter, things like
Yeah.
that. And guys, I want to back up 2 seconds. Don't get me wrong. All those things I was mentioning about maybe a fuel pump coming on or twilight sentinel creating a voltage drop, these are
Yeah.
just thoughts. I'm not going out
Yeah.
and testing for this stuff. We don't have enough evidence to invest time in these areas and stay efficient, especially
Oh,
on
yeah.
today's vehicles.
Good point. Good point. Yeah. These are all things we're all thinking of. We're thinking, all right, well, the dome light comes on. That's something where does that circuit go to? Yeah. That's so, yeah, I want to reiterate that, everyone. We're not testing those first, but they're definitely at the top of our mind. We think about what happens when we do this.
And you know what? I kind of, even though I didn't ask you this because you explained this to me initially in an email, I didn't think for a second you did not perform a DTC scan. And on today's vehicles, I'll be straight up honest with you. If we go back to the 90s and stuff, and people would say, if I could list tasks out one at a time, what would I do first? I mean, sometimes back in the 90s, I would have said, well, I'm going to pop the hood and take a look around and see if there's anything obvious, a mouse chewed through a harness. But nowadays, with today's technology and so many computers networked on these vehicles, 100 plus, it'd be better to just sit there and do a DTC scan. And I know
Oh,
that's
yeah.
what you did.
Oh, yeah. Yeah. If I can not pop the hood and fix the car, I'm doing it.
So walk me through, if you can, if you would, please, Keith,
Yeah.
what we see here. What's going on?
Yeah, so just like you said, we jumped in the driver's seat, and the first step of the process, confirm we can actually repeat the issue, and that we know we can set it into condition of failure. That's gonna be important to testing later. So then I always start with a full system scan because I want to know there may be There may be a series of DTCs that are blatantly addressed in a technical service bulletin that specifically outlines this exact fault. I fix so many vehicles off of a technical service bulletin that so closely aligns with my fault. I have to start with a scan. So we scan the car, and there's a plethora of U codes, and it's most of the modules on the mission critical bus, which we'll look at here in a little bit, um, are given a telltale that the engine control module is not communicating. So there's lots of bus off and lots of no comm with engine control module faults across the vast array of all of the modules in the car. This is only a 2013, but there's still a solid 20 plus modules on this truck. It's a high option package Platinum. It's got modules that I think it shouldn't have. So,
Hmm.
yeah, but everything says this doesn't talk. So we have to think of, like you wrote here, which is the culprit, and what's, is it a cause or an effect that we're dealing with? Well, obviously, all these DTCs saying they can't communicate with the engine control module, that's going to be a big part of that. So looking at that, we go, all right, we get it into the failure condition where it's not crank. And I mean, when it's not cranking, you can cycle the key 100 times. It will not crank till you open and close the door. So I was able to get it into that failure mode and do as many tests as I wanted to do. So, and that's fantastic. I
Yeah.
hate intermittence, but
Oh,
there's intermittence, there's randoms, and there's consistent problems.
yeah.
And randoms are really the worst. I classify as an intermittent usually as something that we can probably replicate. And what is it? Jim tells us all the time. Once you figure out what it takes to make a intermittent problem happen, it's not really intermittent anymore. It's you can make it
Right.
do it over and over and over again. So same thing. I got it in the failure mode and used this. I used the factory IDS tool. There are some aftermarket tools that mimic this test now. The only one that really comes to mind is I hate to plug a tool, but the brand new Ultra like mimics this test where you can select modules and run a network ping where it just pings modules over and over and over again. And this traditionally was only an option on OEM tools. So I'm using the OEM tool here. Ford IDS has a network monitor test. I'm pinging the high speed network and the medium speed. And consistently during the failure, the engine control module alone doesn't communicate. So every other module communicates except for the engine control module, which lines up right with our DTCs. So
I
we've
love
got
it. And
more
where are you sitting
evidence that
right now?
that's the issue. Still in the driver's
I
seat,
love it.
haven't popped the hood.
That's the best. Taking the time and thinking things through and a logical approach. This process of elimination, Keith said it earlier. I can't remember if we said that when you and I were pre-gaming it before we started recording, Keith, but our approach now is as we get older and instead of saying wise, I'll say less stupid. we we start to realize all the things we don't have to test. We stop running
Yeah.
around and sweating. We start taking our time and you know, approaching problems logically. And I just want to say something real quick before we move on because you brought up such an important point. Um, do we need factory tooling? It depends. And here's what I mean by that. I'm not saying you need a factory tool to do everything on a vehicle, but understand some tools, aftermarket tools, even ones that intend to do some of these tasks that they claim to do, they just don't do it well. And maybe it's just on that make and that model. Maybe it's a brand new make and it's new software and they haven't ironed out all the kinks yet because they're waiting for some, beta testing feedback. But the factory tool I'll have to say is always designed to handle all the workload for all the nodes on all the networks. And
Yep.
in this way, we know we have the tooling capability in, I'd
Yep.
say 99.9% of the time. So do we need factory tooling? No. But in situations like this, if I had an aftermarket one and I was getting some information that was kind of iffy, I don't know if I'm dealing with a scan tool incapability, which might be fixed in the next software update, or it truly is a fault with the vehicle.
Yeah, and,
Uh,
and and I could have got this same information with an aftermarket tool, even the least expensive. I got a $300 scan tool on the shop that could have given me this information, but not this quickly, accurately, and so well displayed that the engine control module doesn't communicate. And because it's the factory tool, I trust the data I'm looking at. At least in my experience with this year make model, this software version, I'm happy with the 25-second test that I've done there that's given me some rather powerful information.
awesome. So summing up this slide alone, your approach to the problem. You do it, you do it, you do it. It's still got the problem. And now you can keep it in that failure mode. You've
Hmm.
reached out here and you realize during this failure mode, we've lost communication with the PCM.
Yep,
And
absolutely.
the scan tool cannot communicate with the PCM. That's what this is
Right.
saying?
Can't pull
Gotcha.
DTCs. It can't ping it. It doesn't respond back on the network, but everything else does.
Love it.
Important part.
So considering if an ECU, in this case, the PCM is down, we can't just throw a PCM at it. I mean, some technicians would because they don't realize they haven't taken the time or jumped the gun, so to speak, to realize that computers have needs as well.
Yep.
So even though it appears the PCM is the culprit, it doesn't mean the PCM needs to be replaced.
Right.
So
So we
where'd you go from?
Yeah. So I go, well, I got a single module that doesn't communicate. Now I'm going to approach this differently than the whole bus being down. Right. The whole bus is down. I start thinking about network resistances and all the different things where there could be an open or a wiring problem. I start thinking about, how is the layout happening? So I go, all right, I have an individual module that doesn't communicate. I need to check voltage supplies, ignition supplies, wake up signals if it's got them, ground supplies, and communication bus integrity to this one module. But just like any other circuit test, I'm not going to go and just poke. If I go to poke a wire before I know exactly what it's supposed to have, I've already failed at that test. The accuracy of your measurement is only as precise as the variables that exist in there. So if I don't know what it's supposed to be, then who cares what it is? I don't have any
What an
I
excellent
don't
point.
have any idea.
What an excellent point. How many times would you walk up to a car and I would catch a trainee or somebody I was mentoring at this point. I'd say, oh, hold on a second, Junior. What do you expect to see on that meter or on that scope? And if they say, well, I don't know. Now I can appreciate in the name of experimentation and practice gathering information, but before you make any decisions, we should have anticipation on what's supposed to be going on.
Yeah.
What you just mentioned here, voltage, ignition, and wake up signals and stuff. Years ago, I used to call it pig hunting, as in power, ignition, and ground feeds. So pig
Yeah.
hunting, and that's how I remembered it in my mind. Stupid acronyms like that.
Oh
Or
yeah. So we're checking powers, grounds, and comps, right? That's what
yeah,
uh, we've got to check that. And we have to start before we check that, we've got to know where are we going, what are we checking, and what are we expecting. So we got to get a diagram.
and I will mention this. I've seen technicians go to the PCM diagram. In other words, the same area they'd locate PCM outputs like fuel injectors or the throttle body. And the thing is, what we have to remember is that's not going to contain everything pertaining to voltage and or ignition and or ground feeds. We really should be referencing those specific diagrams like you see here. Obviously, there's no load devices, there's no outputs. This is simply the voltage, ground, ignition, wake up signal feeds to that ECU, in this case, the PCM.
It's good that you bring that up because I often get asked a lot, like, Keith, why don't you use the aftermarket color wiring diagrams interactive very often? I have familiarized myself with using OEM diagrams and how each of the manufacturers structure those. And I've learned that there's a lot of great information they add into an OEM diagram. Most of those blue
Yeah.
letters there are hyperlinks I can click to get a location and a connector face view. I can select any of those other more emboldened blue letters and take me to additional diagrams that are connected to that. There is a ton of information in there. I have zoning information, knowing that the letter number combination of a connector or a splice gives me an idea of where it physically is located in the car. And
Yep.
I had to humble myself in the beginning and go read that how to read this wiring diagram section on whatever service information you're using to learn that there's a ton of information there. The fact that it's
Yep.
dotted lines and not solid lines tells me that that connector diagram is incomplete. There's more than six wires, more than four wires on there. So
Did you ever watch? I'm sorry, I did it again. Go ahead.
no, 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 no. Go ahead.
You ever watch a movie when you were a kid? Even if you love the movie, you watched it 100 times, and then you get older and you watch it again, and it's a totally different movie now. There's so much stuff you're picking up on because now your mind's prepared to accept that stuff.
Yeah,
That was my experience with diagrams. I learned how to read diagrams, and then I realized all this stuff in here, all these hyperlinks and stuff, the dotted lines, right? Things like that. I overlooked, and
yeah,
I would say, I'd look at this and my eyes would show me this. And yeah, I see a branch going here, but I wouldn't pay attention to that and how much more components this may feed. It might feed another 100 components. You know what I mean? I don't know. I used to take all that stuff for granted, but it's okay when you're just getting into electronics and basic electricity and wiring diagram analysis. Realize that these symbols represent something, and we shouldn't just see this at a 30,000 foot view. We should be looking in and recognizing things like dotted lines to indicate we're not seeing everything that this, in this case, PCM has to offer. This is only specific to what is pertinent on this page. And I had to learn that over time. And I'm sure you did too.
Oh yeah. Yeah, I spent a lot of times looking at color wiring diagrams on, but the reason I have this one here is most manufacturers do something just like this for us, where they provide us an individual diagram that has all of the necessary powers, grounds, ignition sources, everything for this module to talk. And that's what's great. I don't have to sift through 57 other inputs and outputs like you were saying. This is
Yeah.
what I need. This is
Yeah.
what I need here.
And I'll say generically, we could refer to this as distribution diagrams, as in power and ground distribution diagrams. And that's where you'll find all this yummy stuff Keith has displayed here. It'll save you some time instead of thumbing through one page of diagrams at a time to find one power source here and then finding this on another page and this on another page. Everything pertaining to the distribution diagrams is all here in this one location. Well, what about bus integrity? So you verified power, ground, and ignition feed, but if we can't complete that telephone call, regardless of who's alive or who's sleeping, if that signal never gets there, the message isn't going to get there anyway. So we got to verify communication network integrity too, right?
Yeah, yeah. So and that's what we're doing. We're building our test plan here and looking at how the diagram's set up, how it's organized, any potential points of access that are easy to get to. Again, we're trying not to spend a whole lot of time on this. We're in the driver's seat. We're scanning the car. Maybe we've got our IDS laptop in front of us. We can pull up service information right there in the truck and go, hey, the PCM doesn't talk alone. It looks like it's got four grounds, three powers, two kinds of wake ups. Now we move on to this diagram for the communication bus to see which direction do we go. We take that fork in the road, the powers and grounds or the network communications, because it doesn't talk.
Yep.
So looking at the
Right.
diagram design, the DLC has a direct connection. It's got a gateway style connector, but it doesn't change or reinterpret any data. So it's a direct connection between pin 6 and 14 through the network bus through a trunk and branch style. So we have a main leg of networks and each module kind of kicks off of that main side. And that lends some information to us as well. So it's really, really unlikely that this PCM goes no comm and it be an open in the network somewhere. But
And
we think about
I
that
want you
door
guys,
opening and closing. So could that branch, could those connectors be in the door? Well, looking at this vehicle physically, I don't see how the PCM wiring could go through a door. So we really
I
just
love
don't
that.
see a door opening, closing, have anything to do with the network circuit.
Yeah. Now, a couple things I want to bring to the surface here that some people might just be either overlooking while you're saying this or just taking it at face value. First of all, Keith has left the driver's seat, maybe not, just to grab his computer. He's not running to this vehicle to try and take things apart as fast as possible. He's using the information like stepping stones. The information he has leads him to his next logical test or decision. Looking at this diagram alone, as he mentioned, the configuration, the fact that this is branches, this is truly a bus. It goes from one end to the other, and we can jump on and off the bus whenever we want, depending on where these computers are located. If this bus were broken anywhere, we'd have a lot more than just a PCM that wouldn't talk. So if this one can talk, and this one, and this one, and this one can talk, the odds of this, I'd say it's impossible for these to be broken somewhere because there'd be a lot more. I mean, if it was broken, it'd be right here
Yeah.
in
Yeah.
this area. I'll say south of these
And yeah,
splices. So
that 2 inches of wire on the diagram could be 10 feet of wiring in the truck.
really
Absolutely.
could.
But
It really could.
statistically, an open and closing of a door, when we know there's realistically no way those wires go through a driver's side door, it's
Mhm.
really unlikely. And that's, like you said, it's a logical approach. We want to just kind of, should we go this direction or invest any time in this? Not really. It's not a daisy chain type network. It's not a ring network configuration. It's very robust. This network is architecture is designed to be extremely fault tolerant. It takes a lot
Love it.
to take one or more modules down on this network.
Love it. So again, he's not working on the car. He's doing his research. Now that he knows what he's doing, he's got his test plan. He knows what he's going to test. Um, some people print these out. Some people right click and save. I like to throw things in a folder on my desktop temporarily. When I'm done, I move it to the cloud, so I always have it. But I gather my information, and now I go to the car with a plan in place, and I do my thinking at the computer, and I do my work at the truck in this case. So we're going to test for integrity of the CAN bus. We are going to, meaning terminal tightness at the PCM, perhaps. Who knows? Is that even worth doing? You've already proved we don't really need to. A voltage, a ground supply, a wake up signal issue, just things to consider of tests to perform when we're at the vehicle. So you make your way to the vehicle and describe this picture here you got going on live. What do these pictures represent here, Keith?
Yeah, so we looking at all the data, it appears as like we should probably go towards a wake up signal or power ground supply.
Mhm.
The communication bus doesn't make sense, so we were like, all right, we've got it under failure conditions. Let's check the powers and the grounds. Let's voltage drop them. I like to usually just check available voltage while the load, in this case, the module, is hooked up. And sometimes I'll do it with a test light and a scope, and that's what we've got going on here. We're able to meter and read actual voltage while also applying a test light. So we're just adding 220 milliamps of load, nothing at all that's important. It's a visual aid, right? So I've
Yeah.
got that hooked up and I've got the scope. So if I see a flicker, I've got a flicker and I've got a histograph on the scope using a U-scope. I can kind of see some data. It's easy to take pictures. I just like having double double amounts of feedback here. I don't know how many times I've tested something with a test light and chased a no voltage to only find out the bulb went out in the test light because I dropped it too hard last time I moved it or didn't have the ground connection set up good. I like having multiple test connections. And
Love
when
it.
I'm with a U-scope and a test light, it takes really no additional time, honestly.
Hey, and you techs out there who have not yet purchased a scope or decided, it's too expensive. Am I going to see that return on investment? Keith, what'd you pay for this U scope? What do you think you'd pay for one now? I haven't looked recently.
I think they're sub $200 still for a kit, like a scope
Guy,
with leads and attachments and things.
guys, that's a long night at the bar.
Yeah. I
200
paid more than
bucks.
that for a low end fluke.
Yeah. So you can get started with scopes. I bought one of these, Keith, for motorcycle diagnostics. It was nice to throw in my thigh pocket and go for a ride. Um, but yeah, at the time, I think I paid $150 for it, and it works great. It is a scope, and it's a darn good scope too. Limited on capability. It's a single channel, but you know what? It'll get you into scope testing, and it'll let you
Mhm.
see what it's like to work with visual interpretations of what's actually happening in a circuit. It's going to change your world. It is. It's going to change your ability as a technician.
It's going to ruin you
So
too.
power, say again.
It's going to ruin you too, because the moment that you start get used to looking at voltage over time and you look at a stationary voltage measurement from a multimeter, you start wondering, is this duty cycle? Is this right? What about right now? What about right now?
Yes. Yep. Ignorance is bliss, right?
Whew,
Once you find
yeah.
out, you can't go back. Um, so voltage feed looks good visually. We looks like let me read this here. This, if you can't see this at home, it's about 14 volts up here. So we're key on engine off. 12 volts. We're good to go.
I think we got battery
Um,
stable voltage on there too. For anyone that's wondering, there's probably like a 13.2, 13.7 volt power maintainer on there. So we can keep the key on and do all kinds of tests and not worry about battery voltage dropping out.
love it. What we got here?
So just because all the powers and grounds tested good and voltage dropped, we check can integrity, and we wanted to check it at the PCM. And like you said, drag test and pen tension are huge. So we can't overlook that. I don't know how many times I've checked at a module, back probing or piercing if you're a piercer, and confirmed everything's good here, but you got to check pen tension. And we did all that, but this is the communication circuit. Although most of our information led us to believe it is probably nothing to do with the communication circuit, we would be absolutely amiss not to test it while we're at the termination end there. And this
Yeah,
looks
you're
like
right
a
there.
textbook CAN waveform. It is perfect under conditions. We have data to the engine control module. And there's a myriad of tests you could do with voltage dropping. You could run a math channel and do A minus B and then check in multiple locations and overlay them. 100 different tests. All that I'm getting at is I see good communication integrity to the engine control module from the bus, both plugged in and unplugged with virtually zero change.
And I want to add something to this here. Always consider the limitation of the test you're performing. So, like Keith said about terminal tension, pin fitment. If I'm back probing at the connector and I'm honest with myself, I say to myself, what are the results of this test telling me? It is telling me where I placed my test leads. This is the voltage signature that is coming across. It doesn't mean it made it across the front side of the connector where the connector meets the PCM terminals. That's what we have to test physically. You can't really test that with a scope, but consider those. So we got good integrity here of our bus. So if you're getting a little bit more confident, typically now you had the luxury. I love when this happens.
Yeah.
I'll say people will usually reach out to me after, I'll say when they hit rock bottom, right? They've done everything. They've done this, they've done that. And many times I get the bonus. We put a factory PCM in there and I'm like, excellent. The chances of the factory one being bad, I'm not saying it's impossible, but chances are if they put the factory unit in there and they still have the same problem, they probably made a mistake. That takes the stress off of me about calling a
Yeah.
bad ECU. So you had that luxury in this case. Is that
Yeah.
correct?
Yeah. Artificial intelligence Keith here probably would have called for an engine control module, and a real Keith would have probably called for this too. Had I not been given the information that from this mobile technician who I trusted, I still trust. He said, look, we put a PCM in it because it had powers, grounds, communication integrity under failure mode, all to the module and drag tested and pin tested. Everything was there for this to talk and it didn't talk. We didn't feel good about it because open and closing door rung true of and gave us the not the warm and fuzzies, but we called for it. And so, Keith probably would have called for that brand new shiny PCM2 and put it in. And the results of that follow. We actually programmed it, which I think we got a picture of. Took a screenshot. We got a screenshot from it, but right afterwards, starting system fault. We have the same exact result, same issue. That old
What a bummer.
PCM wasn't at fault.
That's a bummer.
Yeah,
At least it wasn't your bummer.
that's right. I had that luxury that we had already learned that. But under those same conditions, Brandon, do you think you would have called for a PCM?
I absolutely would have.
I do too. I'd
I
like
absolutely would have.
100%. That's why I wanted to be honest with everyone. I'm like, I'm fairly positive Keith would have rolled up and called for a PCM because powers, grounds, and comms. I mean, I want to say the week before I went out there, I had this conversation with one of my techs. We had a PCM that would communicate. It didn't give him the warm and fuzzies. And I said, if you got powers, grounds, and comms and it doesn't talk, man, it needs one. It changed my tune after this car. I'll tell
Yep.
you that.
It's one more thing we got to add to that.
Yeah,
We're going to learn this.
got to think about this.
So this is where we're licking our wounds, right? Typically, if this was you that called the PCM, this is where I get that knot in my
Yep.
stomach, and I say, "Oh boy!" And I'm up all night in front of the PC trying to think this through, and I can't sleep. And we got to ask, what did I do wrong? What did they do wrong? Um, put a PCM in it like we would have, and it's got the same problem. Obviously, there's a possibility the new PCM is no good, and I've ran into that several times. It happens, but it's not typically the likely answer.
Yeah,
Um,
especially when the symptom is this odd. I haven't seen it before, and it exists exactly the same after the replacement unit.
mhm.
So we have to think to ourselves, just like you would, this is a typical diagnostic step. If you're going to call for a part, think to yourself, if this doesn't work, what would I do next? And then do that
I
before
hate
you put the
that.
part in it. Yeah, I know.
Yeah, before that's the key. What would I do next? Um, it also needs this, right?
Yeah.
It needed that too. It definitely needed the computer, but no, I'm just kidding.
Yeah.
How many times we hear that, unfortunately?
Oh, yeah.
Um, but this is where things I would have taken for granted. This is where you caught my attention. I'm like thinking to
Yeah.
myself, wait, it's got voltage, meaning battery supply, good battery supply. It's got good ground reference, and it's got the wake up signal. At that point, I'd be done. It would need an ECU. But I want you to tell me about something you told me a couple of weeks ago. You mentioned an ISPR circuit. I never even heard of that acronym. What does that stand for?
Yeah, somewhere around the 2010 era, Ford started renaming some of their circuits and the ignition switch position run. So this is just a if ignition switch is on the on position or run position, this is a hot and run or start circuit that's shared on this diagram appears as though it's dedicated from wherever it comes from directly to the engine controller, which is true from what we see in the diagram, it's there. And my initial thought was the wake up signal. I'll be honest with you. My thought was, okay, I have a fault that exists that's not always there. So I think there's some kind of power moding fault, a retained accessory
Hmm.
power anomaly, because opening and closing door, we do that a lot in the programming world to let modules go to sleep for retained accessory power to reset on Fords. So my mind immediately went to the body control module that controls with an internal field effect transistor, the actual wake up signal that goes on and off. It's a switch on and off. So I started thinking, okay, if it's not a consistent power ground or COM fault, there's got to be one of those dynamic circuits that changes states to power mode. And I've had lots of power moding faults in General Motors vehicles where ignition switch circuit one is different than circuit two. And so we have an anomaly of a power mode and we're stuck in limbo and things don't
Yeah,
turn on like they're supposed to. So start applying that thought process and going, all right, we need to check these two dynamic circuits, this PCM wake up signal and the ISPR. And the
gotcha.
wake up signal was a simple on off. It functioned as an on off, even shows that it has a field effect transistor built into the body control module that controls that circuit. So I said, all right, this is simple on off. That makes sense. 0 12 volt. And it operated exactly like that. It was on and off under failure condition and not under failure conditions. Seemed to be no difference or anomalies between the two different states in any condition, failed or not failed. So we kind of turn our
Terrific.
attention to this ISPR circuit.
So you're testing this circuit right now. That's what we're
Yes.
about to do. Is that
Yeah.
correct?
Yep.
So let's see. So during key on, we're monitoring the circuit. What do we see here? This looks good to me, right?
Yep. Yep. Battery voltage, totally normal. Key on. It's what I expected to see. It's what we saw under all of our testing when our key was
Mhm.
on and our module was not communicating. So that was no
Now
surprise.
you did something very strange to me here.
Hmm.
This is where I walk away from this circuit and I say, there's nothing wrong. It has everything it needs to work.
Right.
You didn't do that. You stuck around. Watch this.
So
Keith
we go
now
key
turns the
off.
key off, and this is
Yep.
when there's no fault present. This is what we would expect to see. But I'll be honest with you, I would never even test for this. Like, who cares if there's no volts when the key is off? My
Right.
problem's when the key is on. And that's
Yeah.
where my pea-sized brain went, my uneducated brain went, at least in
Yeah.
this realm.
Yeah. What we
But
see
when the
next was a surprise to me. I was expecting to see still a wrong result, but not like this.
Yep. So now we're key on, and the car is broken at this point, right? I'm sorry, not key on, key off. This is a typo, everybody. I apologize. Key off, right? We've got the key in
Yep.
the off position. I'm expecting 0 volts. I'm assuming you're expecting 0 volts. But
Hmm.
look what we got here,
Yeah, I went ahead and turned the
nearly
meters
five.
function on, and you can see almost exactly 5 volts.
It's like, whoa, wait a minute.
Yeah.
I mean, I would have never even tested. I wouldn't even try to have tests for this. In my mind, this makes no sense. Why bother? It doesn't matter.
Yeah. And at the vehicle, before I took that picture, it was a key on and off. And as a class, we were staring at a dimly lit test light with the key off. And that was like, you guys see that? So let's take some voltage measurements and do these tests on, off, on, off, on, off, on, off. We said, okay, when it's in failure mode with key off, it's stuck at 5 volts. It never goes to zero. It's that 4.8 volts to 12 volts or whatever battery voltage is 13.6, 12.7, depends upon the maintainer's on or off. I mean, the whole time on, off, every time, consistently, nonstop until we open and close that door and reset the cycle. And then it goes 0 12 0 12 until the failure. And it's consistent. Just like any other testing we do, we don't want to catch the one single event and then just harp in and laser focus on that. You know, we don't want to like the one anomaly that happens when we're not there, especially when you look at like secondary voltage. We try to sometimes hyper focus on this one moment in time, like, hey, if that's not repeating while we're having the failure, we might be looking in the wrong spot. This was
Yep.
consistently at 4.8 volts, same failure every time when it failed. This is our smoking gun. But we want to know why it's happening to diagnose it, and B, how does it cause our problem? Like why is
Right.
this a problem?
And at this point here, this line in the sand you've just drawn in front of me, this is outside my realm of understanding. This is totally alien to me. And I'm comfortable enough in stating I know what I don't know.
Yeah.
I realize I don't understand any further than this, so I'm going to allow you to take over
Yeah.
and
Well, and
explain
right
because there's
here,
nothing.
this is where you would have gotten and you would have gone down the same path of isolating where the short's coming from. And because we've got to
Yes.
diagnose the car. So at this point, I want everyone to think about this when they think about explaining a diagnostic in their shop to a client or something. Right here, we have a ton of information. It's although we haven't come to a completion of this diagnosis, our analysis and testing has led us to what is the fault. Now we got to find it. So maybe this is where your time frame or your initial analysis that you've dealt with the customer stops, and you get back with the client and you go, okay, here's the deal. We have a short, and we have got to. This is going to take some time. So we know what the fault is. The fault is this is happening on this circuit every single time, and this is a problem. Now we need to investigate why. It's like finding, hey, there's an open circuit somewhere on this circuit. Well, where does it go? Well, it goes 376 feet underneath all the carpet. So time to sell some teardown. But this one we're gonna continue on that research. Like we know there's a fault there. There's some kind of short to 5 volts ish. So where
Mm-hmm.
does this circuit go and come from? Maybe it's simple. Maybe there's two things this ISPR goes to, and we can just isolate the circuit.
And in fairness, in my opinion, if you're doing things honestly and correctly, at this point, if the customer said, I don't want to go any further, you
I'll
can
open and close the
safely,
door.
yep, pay me for my time. And that would be fair. You've taken the customer to the point that we know what's wrong, and they just don't want to invest the time to pinpoint the location. So you wouldn't be ripping them off if they decided to take the car and you still charge them diag, right?
Yeah,
That's totally acceptable, and that's
you
what
know
we should be
exactly
doing.
what's wrong. You just don't know why yet.
Absolutely. So we're researching diagrams here. Now we're going back to the point where Keith said, wait a minute, we open up the door, the problem goes away. Right away, we're thinking retained accessory power. And that's where my mind went when you told me you open the door is
Yeah.
retained accessory power.
And so all we've done here is we've got a series of diagrams that are highlighted. We're taking a page right out of George Minshew's book, the coloring, color wiring
Color
diagrams by the
coding wiring
colors.
diagram.
Yeah, and I wish I had brought
Brilliant.
my hat to put on my diagram hat, but we're going to show you a series of diagrams, and all I'm doing is highlighting here where this particular circuit goes to, because I kind of want to show you how daunting of a task this became at this
Yeah.
point.
So we're tracing this circuit here particularly, and this circuit, we're not following out this way, but this circuit here feeds the switch side of this relay and this relay and this relay, but continues on here to
Yep.
letter J found at hyperlink 1314.
Yep.
So that takes us to J,
Which
which
goes
feeds all these.
a lot of places to the battery junction box for all the trailer accessories, for heated seat control
Oops.
modules.
Yeah.
Yeah, no, you can go to the
To
next one.
S
There's a
and
ton.
then
So
S
yeah. So
feeds
here we've got
all of them.
powertrain control, auxiliary battery junction, transfer case, analog brake, power steering control module. And so my mind starts racing a little bit here because I start to think to myself, am I barking up the right tree? Because
It's a big investment.
if I have a shorted ISPR circuit, but it goes to all these things, the only thing affected is the engine control module?
That was my fear as well when you were telling me this. Why don't everything else have the same problem, so to speak?
Right, right. And that we get to an answer on that momentarily, but not a concrete answer. But we've got a lot of info. So we'll keep going the diagrams. It goes all
So
different ways. So we kind of going left and right here with the diagrams. I just wanted to
as I'm
push.
looking at this, I'm thinking to myself, good Lord, how do you isolate these? What
Yeah,
you don't go unplugging these computers one at a time, although
no.
you could, but that
Yep.
would take forever.
Yeah, but you'll notice all of them originate from the battery, from the body control module, and all of them
Yep.
originate through a fused circuit.
Yeah,
So
and these are all fuses here.
Yeah, I've got a location where we can go to and we can just start pulling fuses. And we do. And of course, it's not fuse number 1 or 22, it's fuse number 71.
Right there. So you pull this fuse and your problem goes away. So
Yeah.
when I say your problem goes away, did you continue to monitor the 5 volts that we
Yeah.
saw
Yep.
and you pulled the fuses one at a time until that 5 volts went away? Is that correct?
Yeah. Goes to 0. Yeah. And then we said, okay, we put it back in and it came back. We took it out and it went away over and over again. And then we took it out and cycled the key and could not get it to replicate, put the fuse back in. And I mean, you know how this goes, Brandon. When you think you found something, you do 10 to 12 cycles of put the fuse in, it fails. Take the fuse out, it doesn't fail. You open, close the door, you walk around, you check all the harnesses of what you're touching, you flex the body control module, all the things you think you could be inadvertently doing, worrying you're starting to go down the wrong path because you're just holding your mouth wrong. It
Yeah.
was 10,000 times consistent. With this fuse
Love that.
out, the car was not broken ever. With the fuse in, we could consistently get it to go again. So from the fuse to this module, there's got to be a short either in the module or in the wiring somewhere.
Or you just sell them a pair of needle nose pliers
Yep. Yep.
and he
We were
takes
going to
the
put the
fuse out and
fuse on a
he's
toggle switch.
So we are down to either a short somewhere on this wire
Hmm.
intermittently, which is highly unlikely, or a fault internal to the left rear heated seat control module.
Yeah. Which is the other thing that makes it kind of odd. I don't know about you
Yeah.
guys, but I don't know how many 2013 Ford trucks that have had heated seats on the rear bench seat you've dealt with. Not a whole lot. I have a
Not me.
17 F-150 Platinum, and my rear seats are not heated.
Yeah, not me. So I know you. Most people would just put the ECU in it, call it a day, but you got to find out why, don't
Yeah, I got to the module, unplugged it, and unplugging the module fixed it. So we knew it wasn't a short in the wiring. So I said, all right, let's open this module up and figure out what's wrong. Where there was nothing inside that module. There was no water damage. There was no nothing. So we went to, okay, there's something wrong in this module. Call the dealership. There's 170 something of them on back order. So we turn our attention to the PCM. Now that I know, I don't know what's going on with this heated seat control module. I'm not allowed to take this module from this truck. It's not a client of mine. We're at a host shop that's hosting an event. When I get back home, I get a control module that fits that truck, an engine control module, and I tear it apart to figure out what about this ISPR circuit being shorted to 5 volts causes this thing to not talk. So now we've turned our
you?
attention to the engine control module we've cut open here, and I want to know where it is. So I start tracing the pin from the ISPR to the board, and that top left of the board, which we've got a zoomed in of, I find this 8-leg chip. Now, for those of you that do cloning and stuff, that does look like an EEPROM, but the numbers on it kind of lead me to a different direction. So we do a
So
little
that'd
bit
be
of a,
this.
yeah, right there. Yep.
This right here is this little guy just zoomed in. Is that
Oh, yeah.
correct?
Yep. Yep.
Okay. So what is
Now,
this component now?
so it's a voltage detector. So we Google that number to see what is it and how does it work? And so I
So
take the
this
part
number
number
right
off
up
of it.
here.
Yeah, yeah. And it comes up with TPS 3711. And I pull up what's called a data sheet. And so this is about 36 pages of how the module's built, its architecture, what each pin's for, every piece of information about it, all the engineering documentation. And I'm reading through a lot of this, and I'm just trying to find how is 5 volts getting to this when it's supposed to be 0, make it not turn off and then it doesn't turn on, or what's happening? What causes the PCM not to talk? So as Brandon's pointing out there, we have this hysteresis area where there's a threshold that must be crossed. So for this switch to turn on, it's got to be off first, but it's got to turn all the way off. And so there's some
So,
voltage information in there. And on the
so let
next
me guess.
page, yeah, yeah,
The
yeah, go ahead.
the 5.5 volts we suspect right now, the 4.5, 5 volts we saw would probably sit above this lower threshold.
Yeah. Yeah, I
That's what we're
suspect
suspecting,
it's
right?
it's right in that gray area of it doesn't want to work. So looking at the power
So
on
what's this
reset
mean?
voltage diagram, we recognize this module has got to go below 2/10 of a volt to turn off, which means it's got to go below 2/10 of a volt to turn off so it can turn back on correctly.
So this is your home run right here. This is no longer I got a good feeling about this. This is proof. This is
Yeah.
concrete evidence in black and white.
Yeah, and there's more to this inside the engine control module. This is not the only part that powers it on, right? The ISPR comes on, so does the wake up. So if the wake up turns on X, but the ISPR turns on Z and Z doesn't come on and X does, apparently that combination allows it not to communicate. That we've
Interesting.
got
Okay.
stuff. And I monitored current on this module on the bench when I applied proper um, wake up and ISPR, and then I monitored it when I only applied proper wake up and not
Mhm.
ISPR, and it still pulls more current than when it's all the way off, but it doesn't pull the same amount of current. So it pulls about a
Right.
half an amp when it's on to talk, and it pulls about 3/10 of an amp when the ISPR circuit doesn't work. So there are some things come on the circuit board, but not everything.
Got it. And this is the part I was talking about. This is beyond my level of knowledge and understanding. I realize that, so it's never going to bite me. But I know that this information's out there. If I want to educate myself in this realm, you can do it. So, questions here.
Yeah.
What does this 5 volt mean? What is the consequence? It's pretty much what you just told us. That 5 volts is required. Sorry, that 5 volts is not allowing this to see logic zero. So computers are binary; they're on and they're off. There is no, well, we see you intended to turn it off. Computers aren't smart; they're programmed. And if we program that computer to say, "Don't turn off until you've crossed this line here," well, if I'm sitting above the line, no matter how far I am above that line, if I don't cross that threshold, it doesn't turn off, and there's no gray area. It's black or it's white. And that's what we're pretty much stating here, isn't it, buddy?
Yeah, it's literally a 0 or a 1, nothing else.
Yeah. So I love it. And here's the best part. Keith, of all people, I don't want to say is the least likely to need further education. I'm sure we all need further education. We got to keep growing as technicians as technology continues to grow, so we can stay sharp and stay not only accurate but efficient. But of all the people that need to dive this far into this, Keith is not one of them. He knows this stuff, but he still did it anyway. He invested some more time, or even want to say wasted some time, because this gave him peace of mind. And it certainly opened my eyes up to possibilities that I didn't even know existed. And my point is, I would have stopped at checking power, meaning voltage supply, key on at all, voltage at all times, ground, and ignition on, voltage available with ignition on. Once I had those three, I had good communications and terminal integrity at the connector. I would have thrown a PCM at it. And if I tested again and came up with the same thing, I would still say, I think it needs another PCM. And I'd maybe call a friend that hopefully could point me in the right direction. But I can't tell you how many of them probably would have said, no, it probably is another bad PCM, Brandon. Do you agree with that?
Yeah, yeah, I was in the same boat. I mean, you give me too much credit here. I really spent some time going, okay, what am I missing? What's not working right? Because I was of the same camp until I really encountered this, and I got so incredibly lucky that someone else already did the PCM work. I got to look like the rock star that figured this out, and then they figured part of it out. And like I said, that there was more. The mobile tech that had been working on that's a friend of mine, I told him, please don't tell me what you know, because he said, if you pull fuse, when I got done and I got that, he goes, yeah, I figured that when you pull fuse 71, it fixes it. We just hadn't got to why or how yet. And accessing that module was a fairly labor intensive. And, we had a team of technicians there at that shop. So we kind of had an infinite amount of time to tear it apart. And we were given all the right things, right? We weren't set up in the, I'm by myself in a bay, I'm flat rate, I gotta make hours this week. None of those things were on our plate. We were in a learning environment.
I love that. And the learning environment, that's the key words here. If you wouldn't mind, Keith, before we cut out of here for the night, can you wrap this up in one fell swoop here? Talk on these bullet points here, because I know they're extremely important. This is the takeaway of the entire thing. All the fun stuff is what we talked about, but this is the real point.
Yeah. Yeah. So I use the you don't know what you don't know all the time. And I have 100 different examples of that. This is just another one of those where until I ran into this, I was of the power grounds and comms is all it needs camp. I didn't think about powers, grounds, and comms at the right times and off at the right times. So now I've got a new caveat to add when I talk about it.
Hmm.
I changed a lot of my classes, had to change because of this. This case study is now in multiple classes because it's an important part of network. It's an important part of voltage, everything. So you've got to understand and be receptive to you can learn new things and there are new things out there. Doesn't matter how long you've done this. I learn every day that I didn't know that. And especially, when we go to work on a 2025, we have the same amount of experience. It's only been out a year. So we,
Yep.
there's new things every day. So then I got to ask why. And that's where this went, right? When we went to ISPRs failed and shorting to 5 volts, that's causing the problem. Why is that causing the
Why?
problem with this module? I got to know why does it happen this way? I don't understand why it affects only this one module. And to get to the point of where we didn't really answer that question is I did not tear every other module apart in the car to see why ISPR didn't affect it that way. My only pointer I can give you is I've pulled a bunch of modules apart and PCMs are different, right? There's a lot more logic going on. They're command of so many other individual integrated gate bipolar transistor bridges that control multiple things, tons of MOSFETs that control injectors and coils. And so there's lots of power moded sections inside of this module versus
Hmm.
something dedicated to maybe just turning a fuel pump on, right?
Hey,
So the why of why it affected only the PCM is the most complicated. It's the only one that uses that particular on-off circuit.
like power mode. And you know what? To hammer home the point, why, Keith, if you had cut this PCM open and you had found that there was water ingress in there, your answer to why isn't it's just a PCM. Now we have to go find out why is there water ingress, and we'd be checking window seals and weather
Yeah.
strips and things like that, or
And
holes
that,
in the floor.
and that's why
But
we
this is the
tore
importance of asking why.
That's why we tore that heated seat control module open because it's behind the back seat. And we thought we're probably going to find water in it. No, we didn't find water in it. And that's when we went, okay, now that I don't have the time to diagnose that because I can't take this module with me. Why does it affect the PCM? And that's why we went this direction. But when we called and there was 172 on back order, okay, this is a high failure rate item for what it is. But realistically, think about the two big variables. How many people with these trucks get in them and turn the key on and off multiple times without and start the truck without opening and closing the door? And how many of those trucks have a rear heated seat control module?
Yeah.
It's probably one, and I found it.
Yeah.
So,
Very, very limited.
so to bring it back to reality, though, to not just be a big, fire and brimstone case study, 99% of communication issues will be solved by power, grounds, or comms. I can tell you in all my career, my
Hmm.
thousands and thousands of modules I've diagnosed, it's a power, a ground, or a communication circuit that's missing all the time. It's rarely this. This was one that taught me a lesson to think, to not just take it at face value and know there's this whole other level that I didn't know that I didn't know. So this was an extraordinary effort. I don't expect everyone out there to go to this level at all. This is extremely crazy. I love doing the other case studies of stuff that everyone else will see. We did the one with looking at oxygen storage capacity. It's a blast, but it's also really fun to drill down into these one percenters, and it teaches me a lot. Something I will get
Yeah,
to carry on to other vehicles throughout the rest of my career.
it really is. And when you guys, I keep saying guys, I'm sorry, guys and ladies as well. When you attend classes and you study and you watch episodes of Wrench Tales where we get to speak with technicians like Keith that are willing to share their knowledge, the best part is we can learn from them like a bird on their shoulder without feeling the pain directly. So
Yeah.
let Keith screw up the vehicles and tell us what he did wrong. And then
Yeah.
we can learn from it. Try not to make his same mistakes. But man, I truly did learn from this one. So I got to thank you, buddy, because as you wrote here, extraordinary efforts can fix the 1%. Not many people would take the time to cut open an ECU,
Yeah.
especially somebody who does mobile for a living and who runs a shop for a living, right? Time is money, and you can't be efficient and as profitable as you can when you invest time doing research like this, but it's a necessary evil.
Yeah. Yeah. It's not always the most profitable job, but it's the one that I learned the most from. and that makes it profitable for me.
Man, Keith, a million thanks, buddy. I'm finally glad I was able to get you to sit still long enough. Please send my love to the girls, and looking forward to seeing you all coming up soon. I guess where I see in South Carolina,
Oh yeah, yeah, I'll
North
be
Carolina,
there.
excuse me,
North Carolina, I'll
North
be there.
Carolina. Great, awesome. I'll catch up with you. Guys, in the meantime, make sure you check out the rest of our episodes at the Motor Age YouTube channel. This is Wrench Tales. Again, here with my really good buddy, Keith Perkins of L1 Auto out in Tulsa, Oklahoma. Keith, a million thanks. Go grab yourself some dinner, my friend, and I'll catch up with you next time. Keep saving that info. We want to get you back on here, okay?
Absolutely. See you next time.
All right, my friend. You guys take care.